Welcome to this lesson on galvanic cells. In this video, we'll explore how chemical reactions can generate electricity. Galvanic cells are the fundamental technology behind batteries and many other electrical devices we use every day. A galvanic cell is a type of electrochemical cell that converts chemical energy into electrical energy. This conversion happens through spontaneous redox reactions, where electrons are transferred between chemical species. The key word here is spontaneous, meaning these reactions occur naturally without requiring external energy input. Every galvanic cell consists of four essential components. First, the anode, which is the electrode where oxidation occurs and electrons are lost. Second, the cathode, where reduction takes place and electrons are gained. Third, the electrolyte, which is an ion-conducting solution that allows ions to move between the electrodes. And fourth, the salt bridge, which maintains electrical neutrality by allowing ions to flow between the two half cells. Let's visualize the structure of a typical galvanic cell. On one side, we have a zinc electrode acting as the anode with a negative charge. On the other side, a copper electrode serves as the cathode with a positive charge. Connecting these two half cells is the salt bridge in the middle, which allows ions to move between the compartments while keeping the solutions separate. Now let's examine what happens at each electrode. At the anode, zinc metal undergoes oxidation. Zinc solid transforms into zinc 2 plus aqueous ions, releasing 2 electrons in the process. At the cathode, copper 2 plus aqueous ions undergo reduction by accepting 2 electrons to form solid copper metal. These electrons flow from the anode to the cathode through an external wire, creating an electric current. When we combine the two half-cell reactions, we get the net equation for the entire cell. Zinc solid reacts with copper 2 plus aqueous to produce zinc 2 plus aqueous and copper solid. We can also represent this using cell notation. The vertical line represents a phase boundary, and the double vertical line represents the salt bridge separating the two half cells. The cell potential, denoted as E-degree cell, measures the voltage produced by the galvanic cell. It's calculated by subtracting the standard reduction potential of the anode from that of the cathode. This value tells us how much electrical energy the cell can provide. Standard conditions mean 1 molar concentration, 25 degrees Celsius, and 1 atmosphere pressure. A positive cell potential indicates a spontaneous reaction. Galvanic cells have numerous practical applications in our daily lives. They power batteries in our phones, laptops, and other portable devices. Fuel cells use galvanic principles to generate clean energy for electric vehicles. Large-scale energy storage systems rely on galvanic cells to store electricity for power grids. Additionally, they're used in various chemical sensors for detecting specific substances. Understanding galvanic cells is crucial for developing better energy storage technologies for the future.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.